Well, as you can hear, this isn't going to be much of a repair video. So what we have on the bench right now is a pretty unique tuner. It's FM only, and before you kind of groan and say, oh, another tuner video, and worse yet, another tube tuner video. Well, this is actually something a little more special than that. This is a Marantz Model 10B, and it's considered among many people in the audio, hobby, as probably one of the best, if not the best, vacuum tube tuner ever made. At least for just FM broadcast. And of course there's all kinds of varying opinions on that, and I don't have an opinion either way, because this is the first time I've ever seen one in real person, and it's the first time I've ever gotten to play with one. Now a friend of mine sent this over. He owns it, and wanted me to go over it and check it out and repair it if it needs to be repaired. And well, there's really not much wrong with it. So I thought I'd take the opportunity in this video we'll go over the couple little things we can. We'll do some tests on it, and we'll talk a little bit about this very unique tuner, how it was built, and then most of this is stuff that I've kind of done some research and that my friend sent me that I've read through, and it's actually was very interesting where this came from and how it came to be. Now, this was back in the day when Marantz, under Saul Marantz, the founder of the Marantz Corporation, were still producing audio equipment here in the United States. And later on, it got sold off to another company, ended up, having a very good run of it with audio gear even after this. And even things like what we see today, for instance, this Marantz 2240 and all that awesome gear from that era. And Marantz is still in business even today. So this was kind of the swan song, I think, of the vacuum tube tuner era. And what they were trying to do, at least from what I see, is they were trying to produce a 1970s, 1980s technology type of stereo tuner using the technology that existed only in the 1950s and 60s. So a lot of challenges had to be overcome in order to do this, and therefore you'll see why this thing is so unique and why it took so much effort. These were all hand built, and there was a huge amount of effort that went into the design and refinement of these while they were being made. Now, these were produced somewhere around 1965, and that's pretty significant because that's pretty early on in the multiplex stereo era. Because remember, we really didn't start to see any kind of stereo broadcast or any commercially built equipment till somewhere around 61, 62, 63 is when things really started to go. So really it was only a couple years into this that they did this. So if you go back to some of my previous videos, for instance, some of the Scott receivers that I did from that era, some of the Fisher gear, you'll see that the multiplex circuits back then, and even the IF strip, used in the FM tuners, were not nearly as advanced as this one is. So you can see they were trying in this one already to come up with different ways to refine, FM stereo and make it sound almost audiophile quality, if I can use that word, whatever that is these days. I have no idea. But anyway, no matter what, I have to say, after playing around with this thing, and I've done nothing to it, right out of the box, this is how it sounds. It sounds amazing. I mean, it's very sensitive. It's pretty selective. It has very good frequency response, and it has very good tonal quality. And when I say tonal quality, I mean that it may not, be totally flat, from 30 hertz up to 15 kilohertz or whatever, but it just has a very warm, very smooth, very consistent sound that's very pleasing to the ears. It doesn't tire you out to listen to it, and I like it. That being said, you know, a lot of the newer gear from the 1970s and 80s, when they went to solid state and started to go to, you know, even things that have PLL and loops and things for the multiplex, you know, that's when it really started getting great, and you would expect that kind of sound out of those, but they managed to get a similar kind of response using the technology they had at the time. Now, one thing right off the bat that I see is this has a scope on it, and it's similar to some of the later Marantz equipment. So I went and I did a really high-end solid-state Marantz tuner, and I did a video of it. I also did the Marantz 2500 receiver. Both of those had similar scopes. They had the blue phosphor instead of the green, but regardless, they do the same thing as this one. So this was really the first one where they actually did that. And right now I have it set to the tuning, and you can adjust the positioning of it, and the pots need to be cleaned, of course. But you can see how dim that is. So this is really going to need a CRT replacement, and I think we have a brand new old stock replacement, so we are going to do that. I've read and heard that, you know, that there are opto isolators, which I've already checked out in this, and they basically use a couple of light dependent resistors in a little sealed container as switches to turn the mono and stereo circuits on and off. And I guess they did that to reduce noise, so you know, for low noise purposes, instead of using a relay or something like that. Now, I don't know why they couldn't have used just a vacuum tube to do that, or something similar to that, but they did this LDR, and it's a pretty elegant and simple design, but apparently the LDRs had a lot of problems, and a lot of them wore out. On this one, they work absolutely perfectly. There is no need to mess with them. The other thing that I was made to understand is over here on the right-hand side, I believe, this is your IF strip, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 tubes in there. And the IF circuit on this is purposely made not to be easy to align, or even to get to be able to align it. And they do that because the way this thing was designed, it's built to never go out of alignment. So if one of these tubes were to go bad, you just replace the tube, and it self-calibrates to that tube. At least roughly how I understand it. When they do this, they did it at operating temperature, meaning they put this whole thing in a special oven that they built specifically for this model. They brought it up to a specific temperature, and then they very carefully did the alignment. And then that way, when this thing goes out to its owner, you turn it on and you let it sit there for a while and run. And once it hits that temperature, and these tubes run pretty warm, I mean, you can really feel it. Once they get up to temperature, this thing just locks right in, and it's perfect. And there's never a need to play with it. The only thing I noticed on it is, and we're going to look at this, the stereo separation adjustment could probably stand a little bit of an adjustment. Although it sounds good in stereo, I think we can make that sound a little better with some tweaks. Now, I know there's a few folks out there that I read about that have done some modifications to these. They've swapped out some capacitors for different ones. There's a voltage doubler circuit in the power supply. They increased the capacitance of the capacitors so that there's less ripple on the power supply. Although I just don't see any indication that ripple or anything affects anything. Maybe you could measure it in there, but I surely can't hear it. And I think if Marantz went so crazy on scrutinizing this design, I think if it really needed that, I don't think the expense of a little bit bigger capacitor would have stopped them from using that. So I really think a lot of that is not necessary. And I wouldn't want to change this anyway. This is really a piece of history. It's kind of a museum now. It's no longer something, I mean, you could certainly listen to it every day. It's, beautiful sounding tuner. But really it's not something, if I want a top performer, I'll get a more modern one that's more plentiful and use that. But I don't really want to mess with this thing too much. A lot of the low value capacitors are NP0, so they won't drift with temperature or anything. It's a bulletproof design. Now for starters, the dial pointer was broken off and they sent it in this little bag, so we're going to have to fix that. There's some crud on the inside of the glass and I'm going to have to remove that, and I guess that's a little bit of a chore on these to do and clean that. And we have to be careful because it's reverse painted, and the paint that they used obviously is not very durable, because if you look right down here, if this thing will focus for me, you can just see right around there how that number 2, and that's the paint just chipping off and moving around. So we're going to have to be extraordinarily careful with this. And then, of course, if I can get that CRT, we'll replace that. We'll look at the stereo separation and see if we can adjust that a little bit and clean the potentiometers. And I'm not going to do anything more to this.
At times, around 29. You probably heard about this, maybe not. Willie Nelson and the Farm Aid crew planning with financing options to fit your budget. Go to mybobs.com.
Boundary right. Slot to the left.
Just like we make it work sleeping next to a
So you can see with almost no, I've done nothing to this thing, and it is bone stock. No one has been in this thing. I looked at it. I took the bottom cover off kind of ahead of time, checked it out when it arrived here, and basically this is probably how it came out of the factory. And looking at some of the rust that I see on the screw heads, it probably sat in a basement in storage for a while and was not used. This transformer case appears to be made out of like pot metal, so it won't rust, but the paint doesn't adhere very well to it, so the paint is flaking a little there. Other than that, not bad. So let's look at the underbelly and see what that looks like. All right. Well, we have the bottom cover off, and you can see this thing was completely hand-built, from what I understand. And again, I'm not a historian on this thing, so, I'm only going by what I've been told and some of the things I've been able to read. But taking a look in here, this, and this are those LDRs that we were talking about. And if you notice, these ones have 6 wires. Now, you might be familiar with these from guitar amplifiers when they're using the tremolo circuits. But the difference is they only have one LDR and one neon light. And in case you don't know what I'm talking about, let me show you. So this is a neon light. This is just a test one that I use. You can see it right here. And you put a high voltage into it, and there's neon gas in there, and it has that little orange glow. So I'm sure a lot of you have seen that before. And what they do is they take one of these, and then they take one of these. Let me get one out if I can here. And this is called an LDR, or a light dependent resistor. And really that's what it is. It's a resistor that changes its resistance in the presence of visible light. So, or sometimes they, depending on what spectrum they peak at, it can be infrared or ultraviolet light also. But let's take a look. We'll connect a meter to it and kind of see how it works. So when we connect this to our ohm meter, you can see that now that it's in light, it's low resistance, it's below 1K or below 1,000 ohms. And if you cover it up, you can see that the resistance goes way up. See, now we're up over 1 mega ohm. And it'll go up further and further if I seal this better. And that's exactly what this does. And all they're doing in the circuit, and I do have a schematic here, it's a pretty simple thing. I don't think this is a very fancy circuit, but here's two of the LDR modules. And you can see the neon light, and you can see the two CDS cells in there. And there's two CDS cells there in a neon light, and that's these little cans over here. And all that's happening is when this light comes on, which is indicating the circuit over here is telling it that there's stereo, and it wants to turn the stereo on. These turn on, the resistance of these will drop way, way down. Okay, let's put this down here a little bit so we can look a little more carefully at it. So the resistance of these goes way down, and you can see they're connected to the grid of your AF amplifier. And this is the signal coming off of your stereo. So this is your left and right channels come through here, and they feed into the inputs of the AF tube. So of course when this resistance goes way, way, way high, then it's going to block the stereo output. And when it lights up and this goes way, way low, it allows the signal to the grid and you get your stereo. So the resistance isn't that big of a deal because it really doesn't affect the sound that much. You know, it just has to be really high to block it and low to pass the signal. It really doesn't have anything to do with like volume adjustment. Although if the LDR fails and it doesn't go down to low enough resistance, it will affect the signal and make it imbalanced or not work at all, not switch into stereo. And so either I don't know if the neon light goes bad or if these CDS cells are going bad, but there's a lot of reports that these are defective and they either have to be rebuilt, which we could rebuild them. I mean, I don't think it would be hard to do. As a matter of fact, I don't even know what resistance they are. I think we could probably measure it. Let's check and see. Okay, we have an analog ohm meter connected on here. And as you can see right now, it's set on the highest scale, and I'm barely reading anything at all. And I also have a very heavily current limited voltage source that's going in here. I mean, I'm going through a 470K resistor with a reduced voltage, and on the schematic they normally will have 295 volts DC with a 680K dropping resistor. So this is only going to partially turn this thing on, but let's see how it works. So turning power on to the neon, and you can see right there the resistance drops, and it drops to about 50K. Well, actually about 40K, 47K. And when I turn it off, the resistance goes back up. And of course, if I would have put a little bit higher voltage in there, it would drop below 1K. So just kind of shows that these things work. Again, don't try to do this unless you know what you're doing. You could, you know, put power where you don't want. But I just wanted to show you how these LDRs work. Now some of this I'm going to do to document for the owner. So this video might be a little strange. Remember, this is serving a purpose, not just for entertaining you. I get not a lot, but every now and then you get a troll that comes on and says, your video is boring, or your video doesn't teach me anything, or whatever. Well, not all of them are going to be for that purpose for you, so you'll have to come back for the next video, and you know, it's the way it is. So anyway, here are the 4 electrolytic capacitors, and then there's some electrolytic cans. I did check them all, and the ESR is perfect on them. They really don't need any, they don't need to be replaced. But again, from what I was reading, these are the ones they're talking about for the voltage doubler circuit, and you can upgrade them to a higher capacitance, and it'll reduce the ripple and so forth. But again, I don't really think that that's going to be necessary on this. It works. This design works as it is. And you can see we can go in here and they all check good. Look this one down here. Just a hair below the other ones, but I would say these are all good. And I checked these ones in there as well. They're good. I'm not going to change these capacitors. I'm just not going to mess with it. Again, this is a piece of history. It's a piece of history that still works in its original form with all of its original parts. I don't think this is something somebody's going to use as a daily driver. It's a novelty now to kind of show the technology and how it worked back then. I just don't see a purpose in upgrading all that. Okay, what we're looking at right now is a very clearly received stereo signal, and when I'm in stereo mode it looks very good, but when I go to right only and left only, you can see I'm not getting perfect separation. Really what should happen is the one channel should go totally flatline in a perfect world, the other channel should stay up, and that could just be an adjustment that has drifted a little bit. And if I put this in front of you here, right here, right around where those LDRs are, there's a stereo adjustment, and that's right here, and that's your separation pot. And that is down here. That's this little pot right here. So we're going to take an alignment tool, and we're going to see if we can get that to adjust. I have a feeling it's just going to take a little bit of a tweak to get it to work. But these pots are kind of, these are rheostats, wire wound pots, so they're a little bit hard to turn. So I'm going to just take my time and hold it, try not to shock myself. And you can see how it jumps when we move it. And look at that. Whoop, went the wrong way. There we go. That's pretty good right there. That looks better. Now let's go to, that's left channel. Let's go to right channel. And of course, there we'll hit the sync. Perfect. Perfect, perfect. This thing should have beautiful stereo separation now. And then we go into full stereo. Everything still looks good. Okay. So let's go back down here. And I'm going to put the bottom back on this, and I'm going to just clean these clean these little controls a little bit and get them cleared off, and then we're going to put the bottom back on so we can test it again. Okay, we have the bottom back on, and we're going to remove the front faceplate so that we can clean the glass and check the lights and all that. And believe it or not, there is a detailed procedure how to do that. So we're going to follow that and see if we can get this to come off. Now, these two little tiny buttons here are not buttons. They're actually knobs. And we're going to need to try to remove them. They're very, very tight. So I'm going to see if I have... This is a set of removal pliers, but I don't think they'll get small enough to be able to remove... Oh yeah, I guess so. This will not mar the... You can get these, I think, on eBay or something. But they're knob removal pliers. You can see they're real smooth, and as long as you're real careful, you can remove these knobs even when they're tight like that. Okay, let me get these two. Wow, those are just finger tight. Okay, we'll take those off. Now once the knobs and the faceplate nuts are off, we're still going to have a little bracket in the top that holds it. So we have to take the shield, this back shield off, and there's a couple of screws that hold it in place. Just two upper ones. And we should be able to remove that, just like so. And look at this, it is in absolutely perfect condition. So that's good. Usually the things you see that come onto my channel here are always a mess. But this one here is pretty, not too bad so far. Okay, and then there's two nuts. One on this side. You can see it's right there. And then one on this side that we have to remove. It looks like some of these things are working themselves loose. Okay. And then this comes off. Now, I recall, oh, and there's the little spacers. I have to put those over here. And now, to get the dial glass off, you do not take all four of these screws off on each side. Okay, notice there are 4 Phillips head screws at each end of the dial glass. Remove the top and bottom screws only. So the 2 middle ones we do not remove. So I'm going to take those off. So we'll take this one. And this one. And then we'll take this one and this one. And there's a little bit of dust and crud that we have to clean here. Let's see what happens here. And then there is another light that needs to be removed, and let me get that off. And I have to move the camera for this one. There. And I just loosen that. And that's the stereo indicator light. And then the glass. Boy, is that a heavy glass. Wow, there's 2 really thick pieces of glass in there. So we'll have to take that apart and clean it. And right there looks to be where our dial pointer once was. So we're going to have to somehow find a way to get that back on there. All right, we've made some pretty good progress here. Moving along, the owner of the tuner here actually was able to locate a new old stock CRT, and this is a type DG7-32. This one is very dim, and you can kind of see, I don't know if you could see in the camera, it's hard to see, but here in real life you can see the phosphor is all mottled and kind of worn, and it's just not that bright. So he has a new old stock one that he got, and we're going to change that out. We've also taken all this off, and as I showed you earlier here in the last clip, there was a lot of, and I cleaned this up too. I just used a little bit of that Quick Glow, and it cleaned up very well. And the big problem that we have is all of the lettering on this, on the glass, is just coming off. It's not even held on there anymore. If I touch that with my finger, it would just fall right off. And so we're going to have to renumber this somehow. Now there's a couple options. I can try to find some water slide decals. I've never had very good luck with those. If I wanted them to go on the back here, they would have to be reverse decals. And, you know, all of that's going to be difficult to do and a lot of work and a big mess. I can try to use one of those little pinpoint paintbrushes and use glass acrylic paint that can, that'll adhere to glass, and I can try to freehand fill that in, but I suck as an artist and I'm not even going to try that. But last but not least, what we can do is I have a label printer, and it's actually a pretty nice one. It's made by Brother. It's called the P-Touch. And I was able to print this, and you can see if we switch it around, the spacing and everything, perfect. I can get it in there. Now this is just a sample that I did, and it is black lettering on a white background tape. However, they make a clear tape with white lettering print, and I ordered some of that, and I saved this as a file in my label printer. So what I'm going to do is when that comes in, I'm going to print this out on clear tape with white lettering. I'm going to overlay it, because this comes apart like so. I'm going to overlay it like so from the underside, and tape it on, stick it on, and then once it's perfectly lined up, if it looks good, then I'm going to go ahead and rub off these letters because they're ready to fall off anyway. If it doesn't look good, I still have this original the way it is, and I can peel the tape off and we'll be good. That's where we are right now. So let me put this back aside out of the way. And even the other reverse printing is very, very delicate. I'm just trying not to disrupt it at all. As I showed you also, this little plastic indicator for the dial pointer broke off, and it was beyond repair. So I had to make a new one, which I think turned out pretty well. I'll zoom you in a little bit so you can see it. And I used epoxy. So if you look from the side here, I just used some epoxy on here. And let me show you what I used. It's kind of interesting. I actually used a lead from an LED. Now why, you might ask, would I use that? Well, the type of metal that's used on this LED is very, very stiff wire. It's square, first of all. You can see how as I rotate it that it's square, and it's very stiff, not like normal copper wire. And what I was able to do was I glued it, protruding this direction, just straight. And then once the epoxy hardened and held it on there, then I just took a very small pair of very fine point pliers and I bent it up straight at a 90-degree angle. Once that finished up, I was able to take one of these oil paint markers, and it's just oil paint, and I colored it in bright red. And that took care of that. And unlike regular wire that's very soft and bendable, this wire's kind of stiff, so it's not gonna go anywhere. So that worked. I was able to find, I got a couple of brand new old stock Type 47 bulbs to replace these, because the ones that were in there, one of them was burned out, the other one was dim. These are nice and bright now. Cleaned the potentiometers. And so this, the new tape, as well as the CRT, is due to come in 2 more days. So we're kind of at a little bit of a standstill. I got the knobs cleaned up, and they cleaned up like brand new. Look how nice those are built. Very well made machine. So we're kind of in a holding pattern here, so when we come back, hopefully we'll have a new CRT, we'll have the dial glass numbers fixed, and have that all back together, and we'll be ready to actually do some testing on this thing. This is a July 1961 copy of Electronics World magazine. This is probably one of the most interesting versions of this magazine I've ever seen. And I actually purchased it because it has some things that are kind of relevant to me in it. And one of the things is there's a really nice article about stereophonic FM multiplex. Now remember, this thing came out like around 65, somewhere around there. And stereo really didn't come out until probably 1961. But here's the cool thing about this. I'll read just a little bit to you. In May of 1960, the FCC issued docket number 13506, calling for technical comments and field tests of these systems from the same station. 6 of these systems underwent field tests in July of 1960 using the facilities of KDKA Radio in Pittsburgh, with receiving facilities at the Uniontown Motel in Uniontown, Pennsylvania. Many hours of test recordings were made on tape, along with the measurement of many pertinent parameters. This data, plus an analysis of all aspects of the systems tested, was then submitted to the FCC in the form of a report as bulky as 2 New York City telephone directories. Now, why am I reading that to you? Well, this is actually since it was July of 61, stereo was a very new thing, and this was introducing the new FM multiplex stereo broadcast system. And this article goes on to talk about it. But that little excerpt that I read to you, the thing that's interesting about that is I was born in Uniontown, Pennsylvania, and I still only live maybe 2.5 hours from there. My cousin, who is, as of this video, is 84 years old, who taught me and was kind of the one who took me under his wing in the beginning to show me, get me introduced to electronics, he was very involved in that type of thing back in that day. And I remember him talking about all these things. So it was really fascinating to me, that to read about it in the magazine as it was written at the time that it happened. People don't realize how much of a contribution to the radio industry the Pittsburgh and that part of Pennsylvania actually played, in the evolution of radio. I just thought it was really cool, so I thought I'd read that to you. But this is a really cool magazine. Of course, they have a crossword puzzle. And I love looking at all the advertisements of these things that they have in here. Tube testers and, multimeters, VTVM meters. Here's a crossword puzzle they do. And little projects that you can build. And there's still magazines like this today, but it's kind of cool looking at the old stuff. And I really would like to find one of these. The Superior Model 79. I've never seen one in real life, but I've read about them. And look at all the things it can do. It's a pretty cool piece of test equipment. Very, very cool. Hopefully someday. I'm a collector. I could part with these things, but it's really cool learning about them and getting them on the bench. And of course, it's also good sharing them with other people. And when people in the same interest as me, we trade off things like that. And the Scott FM Stereo Multiplex Tuner, and this should look familiar to you. We kind of did a version of this tuner that was in a receiver. They take this tuner and they merge it with an amplifier. And we did this, what was it, the 399, I think it was? Did a video on it. And the multiplex adapter, I think we did one of those. So, pretty cool. It's just neat seeing these things being advertised when they first came out in these magazines. But there's so many different things. Headlight dimmer, transistorized, how about that? All kinds of cool stuff. And there's a few things here that was really interesting. Hum elimination in oscilloscopes. remember what scopes were like back then, a lot of the vacuum tube oscilloscopes and things. By the way, I got a really nice ICO 460 that's waiting to be restored. I will probably be doing that in an upcoming video. All kinds of different amplifiers, impedance matching on CB antennas. So I think it's really cool. So this was a very good magazine. I actually have one of those. Well, I know my cousin had one. I had one too. He had two of them, and he gave me one many, many years ago when I still lived with my parents. I don't know whatever happened to it. These are pretty cool. I think Shango 066 has one, and he demonstrated it on some of his videos. But they're really cool. They use a photomultiplier tube to generate the image. But really cool. So anyway, enough prattling about that, but thought it'd be interesting to see that. And yep, we'll be back when this stuff comes in. Okay, I'm still bored, and while the bench is filled up with this thing waiting for me to get things to come in, well, maybe I'll do a little bit more history about this thing. In Radio Electronics magazine, they referred to it as the Rolls-Royce of FM tuners. And of course, it is pretty laid out. I mean, it's got 22 tubes in it. And of course, when they talk about 22 tubes, you have to remember this thing has a CRT and it has an oscilloscope in it, and some of the tubes are for that. But the crazy thing is, this thing has 6 stages of intermediate frequency amplifier. So the IF stage is 6 levels of amplification, 6 stages. Look at that. So here's the first one, and then let me see if I can get a little better view. And you can see it comes in here. It goes through the first IF filter, and then they're all identical. So it's just very slowly and gradually amplifies the signal. Now each filter, normally there would be an IF can in between each of these that you would adjust to peak them. These are the things that were actually aligned in an oven under specific temperatures, specific settings. Once they're set at the factory, you never have to adjust them again. Supposedly, even if one of these tubes goes bad, replacing the tube won't change or won't affect the alignment of this. So it's a very unique design. Of course, these are all identical, so they're just, each stage just amplifies the signal a little bit more. You also have, let's see if I can find it in here. You have 2 stages of RF. So you have 2 RF amplifiers. Here's your balun, and this is that little box up here where your antenna connects. That's showing that down here. And then it goes into your first and second RF amplifier, which are these 6 DL4s, and these are hard tubes to find. The 6 JK6s, these are all kind of a little bit different, And then your local oscillator is your 6 DZ4, and from there it goes up into our IF. So it gets mixed, goes up to your IF, and goes through all 6 stages. Now looking down here is your scope, of course, and you can see there's 1 tube, 2 tubes, there's a transistor, how about that? And the cathodes of some of these tubes actually go to ground through a neon lamp to actually limit the current and to protect them. So if something goes wrong, the tube shorts or something, or there's a high current situation, you can see there's another one. I think that's pretty cool how they do that. Coming out of the IF stage, you go into your limiter. Now you need a limiter on this circuit because the Foster-Seeley detector circuit that they're using does a very good job of detecting the signal and keeping the amplitude up. You don't lose, you don't lose a lot of gain on that. But what happens is it also will pass any amplitude modulation. So any AM interference will pass right through a Foster-Seeley detector or discriminator circuit. So what they do is they put these limiters, and all the limiter does is it only passes the frequency deviation, but it will not pass AM, any kind of AM modulation. So this is what just turns it into an FM only signal. Then once it goes through the detector, it strips the FM modulation off of it and converts it into an amplitude modulated audio signal. So basically when it comes out of here, it's audio. And as it comes through here, and here's your 2 detector diodes down here. Once it comes through there, it goes along and then it's going to go into your multiplex circuit. And that's where you're going to have your, it's going to detect the 19 kilohertz pilot tone. If it sees the pilot tone, it's going to turn on those funny little mono stereo LDR switches. And then that's going to take the 19 kilohertz, it's going to double it into your 38 kilohertz. And then that's where you start demultiplexing and deriving your left plus right, your left minus right, and then eventually it goes through the rectifier circuit here and becomes your left and right outputs, and those go through these little cathode follower amplifiers that kind of buffer the signal and out to the output jacks. It's pretty cool. And then of course you have to filter your 19 kilohertz and 38 kilohertz. That's your trap circuit there. But that's pretty much how this thing works. And then of course there's a muting signal. So it'll look at the threat. You can set the threshold of that. And if you have FM muting turned on, anything that's below a certain signal strength, it'll just mute the whole tuner out so you don't get anything, so you don't hear the static. I'm one of those people, I like to hear the static, so I always turn the muting off, even on modern receivers, because I want to be able to kind of hear the signal coming in. Now, of course, modern digital synthesized tuners and DSP processed tuners, it's a completely different kettle of fish, but analog tuners like this, I like to hear the static. So that's pretty much what we have, and the way they do it, you can see all the components of a modern FM multiplex stereo tuner, and you'll see these later on in the 1970s and 80s in the solid state tuners. This same kind of topology, is generally used, except without having vacuum tubes and having to do all these things. Part of the thing is these tubes, they change, they drift with temperature as they heat up, and therefore that's this whole thing about when they aligned the IF stages in an oven. Basically, they created an ambient temperature, aligned it to that, and they know that when these tubes heat up and get to that temperature, everything will kind of lock into where it was set in the factory. So it's pretty cool. Again, I'm probably not giving the greatest explanation of this circuit, but just a general run through of how it works. And one of the reasons there's so many tubes is 6 stages of IF and then the oscilloscope. And that adds quite a bit. And you have 2 RF stages, and you have 2 limiters, and then you have your detector driver. So it does use up a lot of tubes. And I'm sure this thing does put out some nice heat when it's running. So doubles as a space heater. Now the other thing is when we look at you can't see it because it's inside a metal can in here, but the FM tuning gang, the tuning capacitor, you can see it, see all the sections that are connected together there. It is an 8-gang tuning gang, and it's made by Hammarlund, and Hammarlund was a big manufacturer back then of radio communications receivers and ham radios and things like that. So it was very, very high-end tuner, and even like the fins of the tuning gang were silver plated. Can you imagine how much that would cost to make that today? and it's calibrated at 10 different points. So, and they even custom cut that tuning gang so that the actual dial scale is symmetrical. You'll notice in a lot of tuning dials, the numbers will be scrunched more together at one end, and then they spread apart as you go up the scale. And in this one, they are evenly spaced every, 88, 90, 92, 94, 96, 98, and so forth. Every 2 megahertz, they're evenly spaced on the dial scale. And again, that's a result of the special tuning gang that they use in this. I can't imagine what it would cost to make that type of silver-plated tuning gang anymore. So like I said, this is a really cool thing. And the performance speaks for itself. These things sound really good. And once we get this done, we'll get to actually hear it. Okay, it's all back together, and I put the printed label print on there, and actually I kind of like it because it kind of lights up the dial area when all the lights are out in the room. And when we turn the lights on, you can still see everything really well. And as far as the performance goes,
effects include low red blood cell and low platelet counts.
He's one of the 3 join the millions of people who pre-qualified. Here's your message. Be grateful.
Stevens, well, if you like to clip coupons, I saw that they used to last about...
Yeah, this thing's really, really sensitive. And I'm pretty happy with the way it turned out. It cleaned up really well. The only thing left is I'm still waiting for the CRT, and it's supposed to come in tomorrow. That's the maximum brightness I can get out of it right now. If we turn it into, if we turn it on to mono, you can see even with just that straight line, it's just not very bright. And even that camera makes it look brighter, but in real life, it's hard to see. I mean, it's kind of a ghostly image. But other than that, you can see the stereo indicators working fine. We can read all the numbers. Our new dial pointer looks good. Well, we'll get the CRT in, and then we'll wrap this video up. Yeah, it actually sounds pretty good. So some of that noise we're getting, if I stop the music for a second, some of that has to do with the noise from the computer. It's digital noise, I'll call it. But if I move the mouse around, you'll be able to hear it. If I turn it up loud enough, when I move the mouse, hear all that. But not very much static at all. So, doing really well. So there's the new tube, and you can see it was a new old stock, dated February 15th of 1984. Came in this box. I'm going to put the old one in because it still works, it's just not bright at all. This one's a lot brighter. And like I said, the camera doesn't show you the whole picture because it messes with the lighting and so forth, but much brighter, much better. And I would say this thing turned out extremely well. I'm very happy with the way it turned out. I am not going to try to paint the transformer, nor am I going to try to do any more with the chassis because this is made out of pot metal, so it'll be kind of difficult to get paint to stick to it. and it'll be difficult to get that look without removing the transformer and unwiring it and undoing all of the, the lacing and everything inside. I'm not going to do that. So this is done. What I will do is we're going to see how low we can get of a signal. We're going to try to get down to that 1.5 microvolt and see if we can at least hear music with that low of a signal strength. So let me do that and get set up here, and I'll be right back. Okay, here is 500 microvolts. There's 50 microvolts. 5 microvolts. It's getting a little bit noisy now. There's 2 microvolts. 2 microvolts, and it is locking in on it finally. Yeah, 2.5 microvolts. Not bad. And you can see here's the setting. So we're on ×1, and we're at 2.5 microvolts. Not bad. And we're still receiving stereo. Excellent. So that's it. All done. And I'm going to call this one a wrap. And there's kind of the back view of the new CRT tube. I put some heat shrink around it, just like they had tape on the other one, just to cushion it a little bit. Cleaned up the little rubber bands, and everything's ready to go. So call this one a wrap, and until next time, I wish you all peace, joy, happiness, and good health in your lives, and we'll see you again real soon. Take care, everybody. Bye-bye.